Okay, so here we want to take the limit as x approaches 1 of this rational expression. First note that if we do direct substitution, we'll have 1 minus 1 over the square root of 1 minus 1, which is 0 over 0. And now that's indeterminate. Okay, so that tells us nothing. What we're going to have to do is some algebra to get out from under that. Okay, so here what I'm going to do is rationalize the denominator. So I'll multiply by square root of x plus 1 on the top and the bottom here, the numerator and the denominator. All right, when we do that, we'll get the limit as x approaches 1. Be sure to write this limit every time. Of x minus 1 times the square root of x plus 1. And when you multiply these two binomials out, you'll get x minus 1 on the denominator. Okay, so notice here then that the x minus 1 factor cancels, and that's the indeterminate part. And that'll leave us with the limit as x approaches 1 of the square root of x plus 1. Okay, so now when we do the direct substitution, plugging in x equals 1, we'll have square root of 1 plus 1, which is 2, and that is the limit. Alright, so here's a little bit of a bonus. I'm at wolframalpha.com, and we can check our answers by typing this in. So we have the limit as x approaches, so I'll do a dash and then a right triangle bracket. So that builds like an arrow, and we get the limit as x approaches 1, in parentheses, x minus 1 divided by square root, so sqrt, square root of x minus 1. And then when I hit enter, notice here in Wolfram Alpha, it gives me the answer here, which we just calculated. The limit as x approaches 1 of that rational expression is 2, and then a little bit of a picture. You can see here we have a hole in the graph. And so the limit from the left and the limit from the right is 2. Okay, great.